Hey guys, today's episode is sponsored by Westermeyer Industries Serviceable Oil Floats. Many oil separators contain an oil float to effectively meter separated oil back to the compressors. Westermeyer Industries has taken this concept and perfected it with their new line of serviceable oil floats. These floats feature an improved design with fewer components, allowing for greater manufacturer consistency and up to 20% increased oil flow versus their legacy models. These floats also feature an integrated magnet to shield the oil path from debris and have been field proven in supermarket applications. Westmeyer Industries offer replacement oil floats not only for their own separators, but also cross-compatible models for our competitor oil separators as well. You can find out more about the Westermeyer Industries serviceable oil floats by visiting westermeyerind.com/floats. Once again, that's westermeyerind.com/float. Let's get on with the episode.
Hi, guys. Welcome to the Advanced Refrigeration Podcast. I'm your host, Kevin Compass. I'd like to take a minute to talk about one of our sponsors, Parker Sporlan, and thermostatic expansion valves. How can you guys always have the right thermostatic expansion valve for the right application without having to carry hundreds of valves in your truck? Well, that's simple. Using Sporlan's interchangeable cartridge style valves. The Q valve for conventional and the BQ valve for balance port. It's as easy as 1, 2, 3. It serves thousands of unique applications. So 1, you just select the thermostatic element for your application. 2, you select the body style you need. 3, you select the right size cartridge for the application. These easy to select and assemble valves mean you always have the right valve for the job on your truck. For more information on the Q and BQ valves, visit sporlan.com. Thanks, guys. Enjoy the episode.
Do you guys have a standard layout as far as the communication ports that you use for the ES1? So port 1 is used for this, port 2 is used for this.
So we try to. So one of the things that we use the same equipment, we use the same hardware on the HVAC and lighting side as we do on the refrigeration side. So there's going to be some variability there. We also have circuit only controllers. You'll see those connected to, say, S3Cs or other case controllers. There's no rack on them, or if there is a rack on them, it might be an integrated rack with a Curran or another Novar controller. But we have these circuit only controllers. We have these rack controllers. But typically what you're going to see is your LCDs are all going to be on COM1. On an XEM20R, a lot of people don't know this. The built-in LCD on the XEM20R, that's actually on COM8. So if you look at the transition board, you have 3, 4, 5, 6, 7, 8. Nobody ever uses 8 because the only thing you can add to it is LCDs. That's your LCD COM. So on the ES1, we pretty much standardized COM1 for LCDs. You can daisy chain up to 4 of them on it. They'll all need their own transformers, but you can go up to 4. The challenge is if any of them have the same address, it's going to knock your network down, your LCD network. Another challenge that we run into pretty frequently is if there's supposed to be 2, and it's very common for there to be 2 on these, if there's supposed to be 2 and you only have 1 hooked up to it, it may not talk until you get the other one. Now you can.
This.
What's that?
I just had this and I pulled my hair out. I did an XEM20R conversion to ES1, and I, for the life of me, could not get this damn thing to come on. And it was supposed to be in the other room, or in the electrical room was supposed to be another LCD screen. We didn't have the wire pulled yet. I must have messed with this thing for 5.5 hours before I finally got a hold of somebody. And yeah, lo and behold, I had to hook both screens up to each other.
So one of the things we've been trying to do to mitigate this is we're in most instances, we're sending these out with LCD2 disabled until it's brought on the network and then it's enabled. We don't catch all of them. we've been experiencing such high volume over the past year. I mean, we're doing like 3 times the volume we were last year. I mean, it's crazy. We're doing everything we can to make sure everything's going out smoothly, but you know, some of these things get missed, and it's really important to know that if you're supposed to have 2 LCDs, you got to get them both up and wired in together and addressed prior to hooking them up, or else they're not going to talk. You can see that in your mod configs typically. And if guys don't know how to pull mod configs, it's something contractors should know where to get them and how to pull them. There is a Novar FTP site that any contractor can log into to pull those mod configs. You don't got to call anybody. What's that?
That's still up.
It's still up. So I can share that information with you guys too after we get off, so you can pass it along. But yeah, mod configs still get dropped in those buckets for every job. So you can look at it and go, oh, this is going to have 2 LCDs. You could know in advance. But yeah, if you have multiple LCDs, they have to be present and addressed for them to both come up. What it's doing when you only have one is it's constantly searching for that other one, similar to, you know, when you have multiple Prodigy boards and 2 of them have the same address and it knocks down 30 controllers because you have 2 that are set to 2 because that's how they come out of the box. It's similar to that, where it just kills the whole network. It's not ideal, but it's known. It's another thing we're trying to get away from with the next version of a screen. So LCD is going to be on COM 1. Let me see. I think I have some notes on this. COM 2 is going to be, if you're working on a refrigeration system and you're upgrading it, COM 2 is going to be your new BACnet devices, 9 times out of 10. All your new BACnet devices are going to go on that COM. If you're adding XIO, if you're adding RCC boards, it's going to go on COM 2. Your A, B, and C, or 3, 4, and 5 from your legacy controllers that you're upgrading, those are going to land on COM 3, 4, and 5 on the XEM, or I'm sorry, on the ES1. So part of that is because on the XEM, those COM ports are already 3, 4, and 5. So on the ES1, keeping 3, 4, and 5 is one less step for the programmer to modify. But on those legacy boards, they would go A, B, and C would be 3, 4, and 5. So that's 9 times out of 10, they're going to follow that path. If you have a rack integration, if you're having a circuit controller that needs to talk to a rack controller, those rack integrations are going to be on COM port 6. So that's the majority of the standardization. Now, when you're dealing with circuit-only controllers, it's going to be a little bit different, but your LCD is still going to be on 1. If there's a rack integration, it's going to be on 6. And then you're going to have just cases or circuits off of your other comms, 3, 4, and 5.
Now, because I don't remember, are the ES1s linked together with one of the other COM ports, or is that all done over Ethernet?
The ES1s, they all are broadcasting out over Cat5.
Okay.
So one thing I would say on some of these older stores, the RC2XE technically had a port for Cat5 connection. And in some stores, they landed a port there. I learned the hard way not to trust a 20-year-old Cat5 cable when I stayed at a job until a cabling guy came in to get one in. Definitely test those. One of the benefits of the ES1 that I personally like is because it's such a small form factor, you can mount them just about anywhere. And the best way to install them, I think, is mount them up, get a Cat5 cable going to them, get any new boards wired to it prior to changing over from the legacy system. Get that thing verified, see that it's online, see that they're going to be able to monitor it. You can even test the new equipment that's come in with it, and then start switching over the legacy stuff to it. A lot of guys forget that you don't necessarily need an entire system to change things over. You can change all of your circuits over to the ES1 and leave your rack controlling off the old controller for a while. It's possible to do that because the loads are separate. Where you run into trouble with that is when you're dealing with rack output modules and it's not all circuits on them. You might have some additional controls in there that need to be tied to the rack, and then you have some circuits. That's where it's not going to work. But in situations where, like, say they're adding third-party case controllers, you can get that ES1 powered up. You can get those case controllers operating before you touch anything else on the rack. And then you can switch over everything else once it's all verified.
So for this instance, probably wouldn't work then. So if you had the RCCs out at the cases that had to talk back to the legacy main boards, because they were the ones that were operating the electronic EPRs at the rack, I'm assuming that would be in an instance where it wouldn't work. You couldn't put the circuit controllers on there, right?
So you have RCC controllers going back to the rack.
Yeah. So basically, you said about switching out the cases first, but if the if you're not doing like new case controllers where the RCCs are basically having to communicate with the old legacy boards in order to operate the EPRs, the electronic EPRs,
right?
In that instance, it wouldn't work, correct?
You can if you can transfer the entire COM over.
That's when you just
where you would run. What's that, Kevin?
It's when you just send it and do the whole thing at once.
Yeah. Where it doesn't work is if you can't just pull the whole COM over, and you can actually, if you can pull over some of the boards, it's possible. But then you're talking about running new wire and everything else. But if you can pull a whole COM over, and everything on that COM is what you need to control it, then you're good to go. You got to kind of look at it from a case by case basis. You want to make sure that your inputs are there and your outputs. You don't want to switch over your EPRs if you're not dragging over your defrost and evap controls, right? So you want to make sure everything's getting transferred over. But if you can get most of it over, it's fine. I had a guy called me not too long ago where the only thing he couldn't cut over at the time was the condenser. And he was asking, can I leave the condenser on the old system? And the answer was yes, because it's controlling off of the condenser control module. So it's got its outdoor air temperature and it's got its discharge pressure. So the thing kept running on the old system. He put everything else on the new one. So you can do it in different ways based on what you need. There's some flexibility there. But in general, though, I'll typically, if I'm changing these things out, I'm having both systems run in parallel, at least for a little while I as much as I can on that ES1 before making the commitment. Because once you switch over, you're going that way. You know what I mean?
What I've been doing is I've been mounting the ES1 up in a box, like on the side of the rack, and then I've been taking everything to terminal blocks on a DIN rail right behind the XCM or the whatever's there. And I've been taking the terminal blocks. That way I pre-run the COM, the terminal blocks, and then I pull it right off the baseboard and right in the terminal blocks.
Yep. No, that's a good way to do it. I saw some guys a few years ago that they were replacing RC controllers. And what they did is they removed the RC controller, but they used its base plate as a new terminal block. And they mounted the LCD to the top of that, and they put the ES1 in the cabinet. It looked really clean, and they didn't touch anything. So, I mean, you can get creative with it. I mean, the nice thing about a modular system is there's a lot of options with it. As long as people can find it, I wouldn't hide the thing, but as long as they can find it and it looks clean, typically you'll get away with it.
I've been making them pull new Cat 5 every time, and the last like 3 jobs, nobody said a word about it.
Yeah, Cat 5 and cabling, I mean, that's always been a tricky thing. We've always gotten calls about it. Hey, this thing's not communicating. And it's like, have your guys verified their ports. And, an hour later, they determine, all right, it was us. So it's gotten better. But
unfortunately, with the customer we're all dealing with, I mean, that cabling aspect, as soon as you bring the cabling people in, it just turns into a shit show. Yeah, it turns into finger pointing land.
It's It's definitely challenging. I will give them credit though. They use good cabling techs for the most part.
Yes.
It's something you can really skimp on, and they go for quality with it. They go for security, and I mean they hire some good guys for it. Bad Cat 5 is worse. So I'll tell you that. You got guys punching them down, and it doesn't work. They don't test it. I mean, so yeah, but it's always been a trick. But it's nice to get that controller up and running and communicating before you move on with it. I think there's a lot of benefit to that. Just knowing that it's ready to be monitored the second it's cut over. I mean, you'll sleep at night, you know?
So let me get this straight. So the ES1 can talk with the older Spectrum stuff, right? Talk
Yes.
with the BACnet stuff, and what's are you guys doing a newer network protocol or no?
No, so all of our equipment currently is BACnet MSTP. We're pretty comfortable with that. We'll likely be going in some other directions in the future as we push more edge devices. We'll get into it more, but we have a strategic partnership with Ketatherm right now. Almost all of Ketatherm's equipment has an API built into it. It's designed for direct IP. We anticipate things going in that direction in the future. Currently, our solutions are BACnet. We can communicate to just about all Spectrum modules. There are some that we cannot. There's old case controllers that used to be planted in PVC pipes. And have you guys seen these?
They're all gone. I've ripped them out.
Yeah. So they would put them in a PVC pipe. They'd just slide the board into it. They'd wire it up, and then they'd put the caps on it so that it's watertight. And there's a lot of them out there. Well, there's far fewer now than there were, but those are not compatible with Opus at all. They were old when Opus first came out. They were already unsupported, and we've never gone back to try to integrate them. So those stores need to be upgraded to a different solution. Those had both, they had temperature inputs as well as relay outputs. To replace them, we've been sending Spectrum XIO modules if it can accommodate them. If it's an entire store's worth, it's a totally different challenge. Probably your best bet at that point is case controllers. Swapping them out, having self-contained edge-controlled case controllers in them.
At that point, it's probably up for a remodel, complete case remodel.
Yeah.
I mean,
I would say for the guys that do touch some of the stuff on the building side, NSDs, NCH panels, and your electrical boxes, some of those are out of date.
IOMs too, right?
The IOMs, none of them are going to be compatible for the most part. IOM 2s, most of them will be. So, you know, we do have a cut sheet that says which version we support going back to. We've had a number of arguments because the customer has found some that are older than those versions, older than those firmware versions, but we only tested as far back as the version numbers on that list. So they say, hey, we do have one older, it is working. It's like, okay, well, kind of like a star configuration. Sometimes those work on Opus, but you may have scrolling con loss issues down the line. So it tends to be better to stay within the parameters of what's actually been 100% vetted. But I can share that compatibility list with you guys as well, just for the really old equipment. So
you were saying about the Ketatherm, so they're still using IP. So I'm assuming all their controllers would go back to a main switch, and then you'd have it communicating through your network going over to the ES1. Is that correct?
So we partnered with Ketatherm 2 years ago, and we are taking the lead on selling their product into retail grocery. So into the retail grocery space, it's going to go through our offices. So through the Novar channels, if guys in the field need support on this equipment. The Ketatherm is going to focus more on the industrial side of things.
Mm-hmm.
And what they get out of it is they have access to our suite of products as well. So they can be selling ours into those spaces, and we're selling theirs into the grocery space. The lead product we led off with this partnership was the EVAP Efficiency RE2 controller for walk-in box control. Currently, that is integrated into our system and to Emerson's system via BACnet. So for Walmart, we're following their BACnet spec 4.3, so which is the same that Sporland's following with the S3C. So if people understand, the BACnet device IDs that would be utilized, because there's a specific configuration to line those up per the customer. To match that, it's going to be the same as what they're familiar with the S3Cs. One thing I would note on the ES1 on the LCD, because we do have the majority of our equipment is now BACnet. When you look at the LCD and you go into the networks and you look at the BACnet and you check addressing on all the boards, you're going to see 2 values before a colon, and then you're going to see 2 or 3 values after the colon. That first value all the way to the left, that's going to be your EMS number. So your HVAC controller is typically 1, LTA would be 2, BRAC would be 3, etc. So that first digit is just identifying which controller you're at. The second digit is the COM port it's going to wire to.
Okay, so if you're on rack A controller, that'd be basically, you said that would be number 2, right? Yeah. And then 7th case controller, so it'd be 27, and then the semicolon, and then that's the address of the BACnet address of the device, then, correct?
Right. On the right side of the colon is going to be your BACnet address. So your first value will be the EMS number. So if it was 23, 1:125, you're going to be on EMS2, which is probably your ARAC. You're going to be on COM3 on the ES1.
Yeah.
That's where it's going to land. And then your address is going to be 125.
So that's the one thing I do like about, dealing with the S3C with, on the ES1, where basically I can tell just by looking, because obviously the first one is 485 to the first controller, right? So you can tell where the COM loop actually starts, and then all the rest of them adjacent are going to have, regular IP addresses, behind there.
Correct.
And with Ketatherm, it's not going to be that way, correct?
Ketatherm currently is going to be all RS485 from controller to controller daisy chained.
Okay.
So the benefit is if you have a store with older controllers like RCC 521s, you could replace, say, just one circuit with, say, case controllers, or you could do just one walk-in box without running any new COM. You can use the existing COM.
Oh, it'll speak on the same network.
Splice right into it. That's nice.
Right. The other thing is those controllers are going to have 2K sensors, and 521s have 2K sensors. So you could potentially reuse some of those sensors. Now, the biggest challenge with Ketatherm's equipment is because they do everything through demand defrost, coil placement of their temp sensors is very critical to making sure that you clear your coil during each defrost. So typically the first sensor can kind of be roughed in on a, I'd have to look at the complete drawing on it, but on a RE2, when you're in a walk-in box, you're going to end up with 4 sensors on your first coil and 2 on any subsequent coil.
Okay.
One of those coil temp sensors is going to be critical because it's going to be, you want to place it where frost was last seen on the evaporator coil so that you completely cleared the coil. So on a new system, it's more challenging than an older one. In our documentation, we do have where that best spot is likely to be, but typically you install it, you let it run for a little while, you throw it in a defrost, you watch and see where it's going to have that last buildup, and you may be repositioning it by 6 inches or so. Now, it's a little extra work in the beginning, but once these things run, I mean, you're going to see significantly fewer icing issues than you would with a traditional controller. They're going to work really well. So if you guys have seen the older Ketotherm equipment in the field, I mean, their stuff works really well if it's installed properly to begin with. Coil sensor placement is the most critical part of that installation.
So in like walk-in freezers, like I'm a big proponent. Usually, I like to put it behind the first fan, on basically the like where the distributor tube feeds, because that's basically the first place you're gonna have frost. Whether you have, not enough liquid or whatever, you're still gonna have frost there, right? And then I
Right.
usually try to put it so if the defrost heater's here, and basically I'm putting it in the middle, so I'm not right up on that heat, as well as also not putting it right at the top where all that heat's going to rise. Is that about the location is that you guys put them?
Yeah, so it will depend on the type of coil. We did run into some challenges with the low velocity coils. The placement needed to be slightly different. So we updated our documentation to include the best placement for those. But on your traditional coil, you're typically going to have one on the suction side, somewhere near the bottom, but away from the heater. And then the other one would likely be on the opposite side, in a similar spot, but on the opposite side of the coil. Now, the nice thing about doing a retrofit is you can actually see where that frost always melts, because you have staining and other things where you can typically spot exactly where it's going to go. But on a brand new one, I mean, you got to kind of rough it in and then run it through and just check, see how it actually performs, and if it's close to where that frost is finally melting.
Can you share that documentation with us as well?
Yeah, I emailed that one to you a couple days ago. Do you have that one?
No, I didn't. On the company email?
Yeah. Yep.
Oh, I didn't see it. That's why I was asking.
Make sure I sent it to the right place.
Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with Westermeyer Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now. Horrible about checking my email. I'll try to be real good.
B. Wetzel.
Son of a bitch, you did send it. Damn it.
So, I mean, you can pass that along. It's really useful. What we did to create that document is it's not a manual. It's an install document, and because the customer has a very specific design they're going with, we catered that installation to that design, so they should all be exactly like that. Now, the one thing that's going to vary is your coil temp sensor is going to move based on actual performance somewhat. But aside from that, I mean, that guide will get someone through where to land your sensors, where to wire everything in, how to program it, how to configure it. So when you go in, when you first get into those modules, you want to connect to them via Wi-Fi, which is you hold the back button and the right arrow button. And then you connect to it via phone or tablet or computer, and it'll pop up a web page automatically. If it doesn't, there's steps in there to log into that page manually. You don't need an app. It just goes through a web portal. It's very fast to configure. It's going to ask you the first time you set it up, one of 4 modes. The reason you want to put in the right mode there is because it's going to populate probably 80% of your configurations by picking the right mode. And then once you get in there, you're just configuring a handful of set points that are defined in that manual, and you're all set up. Guys that have done it the first time have kind of stumbled through it. Maybe they spend an hour on the first one. The second one, they spend 10 minutes. So it's a little bit of a curve the first time, but it's not anything to panic over. And with that document, it's pretty much step by step.
It's probably like the older ketotherm stuff, the original evaporator efficiency one, where basically if it has an EPR in there, electronic EPR, you have to tell it it's a supermarket style, so it knows how to operate that. Otherwise, it thinks that it's trying to operate superheat when it's really not.
Right. Yeah. So there's a number of configurations in there for that. So with RCUs, for instance, there's not going to be any EPR, so you got to set it to mechanical. But there's different parameters. The main reason when you first log in, it gives you the option of 4 different system types is because it's going to preload all those defaults. If you choose the wrong one, some of those settings aren't even going to be available for you. When you're going through the rest of it, you're going to go, hey, I'm trying to set the sensor up. It's not present. It's because you picked the wrong mode in the beginning. You got to do a factory reset and start over. So
been there, done that. I've had to do it a couple times on the original evaporator efficiency.
So I've been supporting this product for about 1.5 years now, and I'll tell you, I've had a lot of calls from guys saying they've gotten stuck even after I've sent them this document. I said, did you follow the document step by step? And they said, no. And I said, try it again. And I said, go through it just page by page and just get to the end of it. And then they called me back and they go, that was way easier than I thought. And it's like, okay, there is no extra information in that document. It's just how to set it up per that design. They standardize their design to make it easy. And if people follow that guide through the first one, they're going to have no problem setting up that one and subsequent ones. So highly recommend going that way.
Gotcha.
We are trying to develop some other things to help train people on these. I thought about I do a number of videos for our YouTube page. One of the challenge with this is there's so many different configuration possibilities that it's hard to do a video walkthrough. People will just be like, well, that's not my system, and tune it out. So
you'd have to basically do several different videos. Hey, if you have a mechanical EPR, an electronic expansion valve, this is what you're going to do. If you have, because right. I mean, how many variable outputs do they have on their newer controller? Because I remember them only having one on the original evaporator efficiency.
Let me see. So they are currently running, I want to say there's one auxiliary relay currently, because you have lights, you have your liquid solenoid, your defrost relay. So they have one additional one. It can be used for a number of things. One of the bigger things that it's been used for in the past is what they call permanent defrost. The permanent defrost signal, if you're familiar with the older ketotherm equipment, it's the signal that it sends to an older BAS system. Hey, this system is in defrost. Mm-hmm. That way you can coordinate with a system that doesn't have backnet capability. You can land it on a digital input, and from there it'll know, okay, this controller's in defrost, don't alarm on its temperature.
So some of the other questions I had about some of the Mean.io boards and stuff like that, they're all on the same network as the all the rest of the rack controller stuff?
Yeah, so MinIOs can be on the same network as the older systems. One thing to keep in mind though is MinIOs are incompatible with Spectrum controllers. So a MinIO cannot communicate to an RC2XE or an RC.
Okay.
They do work on the EP2s, but not the RC controllers. On Opus systems, it can be incorporated. So it has a different driver in it. My understanding is on those legacy systems, they have to have a firmware profile for any module that connects to it. The MinIO was developed after it was initially developed for HVAC and lighting. When they applied it to refrigeration, it was after they had ended development on that older software for the RC controllers. So it'll work in Opus, but it will not work on those older systems. And the MinIO is still not obsolete, but we still recommend the XIO modules just because they're easier to manufacture. They're faster to get in, and they're a bit more versatile. So if people are familiar with the MinIOs, the jumper configuration is critical. If you put the jumper in the wrong positions than what is programmed, it can potentially fault the board.
Damage the input, or just fault out the board?
It'll fault the board because the inputs are not reading the way they're expecting. So, for instance, I believe when they're programmed, they're all by default, they're set to milliamp and digital. So they should be in that position unless otherwise programmed, and then they need to be in the correct spot. But that's a challenge, and that's something we got away from on the XIO. On the XIO, when you're switching the type of input, the software itself is determining how that input is going to be configured. It's going to push that change to the board, which can take, I've seen that take as long as 5 or 10 minutes for it to do that update. So when somebody reprograms a board for you to work in a different type of input, give it a minute to take those settings before you complain that it's not working.
Yeah.
And the difference there for the techs that aren't as familiar with it, these inputs can be configured as 4 to 20 milliamp current inputs, 1 to 5 volt DC inputs. That's another thing on the XIO. It can be a 0 to 10 volt DC input, or it can be set as a digital, or I think that might be about it.
And you guys have no problem scaling it, right? So like if you're dealing with certain controllers like the IDCM, where it has to have, you have to start off at 1.5 and then then go from there up to 5. You guys have the full capability to do that no matter what version of Novar.
Yeah, so this is a little bit different for guys that know Danfoss equipment. I believe their relay outputs can double as analog outputs. On our XIO modules, the universal inputs can double as analog outputs. So our 8 universal input board can be configured to have inputs and analog outputs on it.
Okay.
Not relay outputs, but analog outputs. So you can drive a 0 to 10 volt DC out of any universal input on that board. It can be configured for it. Cool. Now, within that range, we can configure it to anything. So anywhere between 0 and 10 can be configured. And then for the analog output. And then on the inputs, anything within 0 to 10 volt DC input can be configured. And we can scale the values to whatever you need.
Do you guys have a solid state relay board that takes the place of like an anti-sweat board, like a sweat miser?
So the RCC 1081 and RCC 1044 they each have a single solid state relay output, but only one on each board.
I just with all the it seems like a lot of different case controller manufacturers going with the pulse width modulation expansion valves. So I didn't know if you guys had an answer for that, because it seemed like RDM, it seems like that's all they're putting in. Danfoss, they're a big proponent of that, So I was wondering what you're doing.
The Ketatherm RE2 and the Ketatherm case controller can both do pulse width modulating valves.
Yeah.
As far as ours go, if you want to use a pulse width modulating valve, you can do it with a 1081 or a 1044, but we only have the one output. So if you want to do multiple valves in a rack house, I would say we don't have a great solution for it yet, but we haven't really seen that application either. One of the one of the biggest strengths of working for Honeywell, and this is one of my favorite parts, is we run into things sometimes where a customer goes, "Hey, I need a board that does X, Y, or Z," and because we have dozens and dozens of control companies under our umbrella, we can actually reach out to them and go, "Hey, do you have anything that's BACnet, Modbus, Lawnworks? Like, do you have anything that fits this?" And oftentimes we can find it. So, the universal BACnet module, for instance, that's something we just plucked from the Honeywell catalog. So there's a lot of stuff out there, and we've run into situations where we need a solution similar to how they do it in Europe. Well, luckily we have a lot of Honeywell offices in Europe and a lot of products in Europe, so we can pull them over. So
No, I've seen. Well, I was looking at. I don't know why. I was looking at something where, like, I saw the ES1, and then I saw a controller that was identical except for it was red. And I'm assuming that's just a different version, a different Jace module that can hook up to it. Yeah.
So yeah, that would be another Jace 8000. So the Jace 8000s are used by a number of Honeywell brands. What I would tell you makes them all different is the software going into them. So for the most part, they're all Tritium based software, right? So they're all Niagara.
Mm-hmm.
But if you ever see a Niagara version in another solution that is not Opus,
Mm-hmm.
it doesn't just look different, its functionality is different. So
Okay.
we have a number of controls, we have a number of solutions, software solutions, that no other part of Honeywell has. Part of that is because we're one of the only Honeywell brands that really focuses on retail refrigeration, right? Grocery.
Yeah.
So we have a lot of unique solutions that nobody else has. Opus used to be developed more in line with how other Tritium products would have been developed. But since then, we've developed a software called ORL, which is the Opus Refrigeration Library. And what the library is in that is we have just a ton of collections of apps, basically, that can be integrated into it so that we're not reinventing the wheel whenever we see a system we saw 15 years ago or 10 years ago or whatever. We can just bring it in and get it programmed faster and have it work. It's much more capable than some of the older systems.
So with that said, your guys' logic and stuff, like in the background, does Opus have the ability to do block logic? The XCM20, I'm not the XCM20.
So Tritium
What?
Tritium actually uses what they call wire sheet logic. So if you think about ladder logic or block logic, um, it's it's sort of like it's designed like an electrical print, right? I mean, it's top down. You're going to follow it in a specific way. One of the benefits of wire sheet logic is you can actually run these things in all directions. So what that allows you to do is it allows you to make much more complicated algorithms, which for some things becomes very beneficial. It can allow you to have tighter control. Um, some of the other things that we're doing on the logic side are, Honeywell has boards now where you can actually push that wire sheet logic into the board itself. So like the Honeywell Edge 10 device, you can load the logic onto it so it works as an edge controller rather than needing to communicate back to the BAS, and you still get the custom logic you can put into it. So one of the challenges we've had for quite a while is, people see our software and they see it as daunting. There's a lot of options, a lot of configurability. You can kind of go anywhere with it. The strength of that is we almost never run into a situation where a customer goes, "Can you do this?" The answer is always yes. We almost never have to tell them we can't do it. It's just a matter of how much application development are we going to throw at it, right? But Tritium is a very powerful tool, and what we did with ORL is designed to be customizable for regular or commonplace refrigeration logic without needing to program it. So if I got to go in there and add a compressor, for instance, I'm not going in and creating wire sheet logic. I'm telling it add one more compressor. And once it adds the compressor, it's going to populate a number of fields that say, is it a variable speed or is it fixed? Does it have an IDCM? Does it have a lockout? Is there an oil pressure lockout? All that stuff is going to pop up, and it's just going to ask you where's the input you want to link it to. You don't have to program any of it. It's just customizable.
So the wire logic is written up, so it's essentially almost pre-canned, right? So it takes that wire logic and populates pre-canned decisions based off of what data you're giving it. Yeah.
So what you can do in Tritium is you can create jar files, which you compress the Java down into a locked file, where that wire sheet logic disappears. So the user can't see where that logic is. It's protected. A number of companies use Tritium because you can actually do custom algorithms and proprietary algorithms, even though Tritium is not. I mean, Tritium is pretty much an open platform for people to develop in. And once they develop their proprietary algorithms in it, other people can't access that. So you can hide your wire sheet logic. In ORL, what we did is when you take a standard DX system and you go in there, you don't see any of our logic because it's already canned in there. So it's just customizable for a standard system. Now, if we have a system that's a one-off and we need to do custom programming for it, we can also do that. We can add that to it. So it's got both. It's got the customizability where a non-programmer could alter it, and it has the customizable options if a customer really wants to do something outside of the box. We've had customers ask, "Hey, can you have two controllers where they're communicating information and changing their algorithms based on, say, performance on the store?" So, if cases are having trouble maintaining temp, can you alter the humidity in the store?
Oh wow.
And you can do that because between each of these controllers, there's actually a Niagara network that links them all together. So they can communicate to each other. Once you bring them into your IP network, they can talk back and forth and communicate whatever you need. Or for Walmart, when we were doing secondary systems and we had some CO2 values we wanted to actually transmit directly, we would either wire them in via BACnet with a BACnet export going from one controller to the other, or we do a hardwire where you get a digital closure off of a relay, like when a vessel is too high. The reason we did that was just if your network goes down, you don't want to lose that failsafe. So there's a lot of ways to skin the cat. You can over engineer it, you can under engineer it, but it's a very capable system. So that's one of the benefits. I know a lot of our competitors are more customizable. For your standard system, it's Opus is actually very customizable if you have the credentials to change it.
Kevin, you're being really quiet over there. I'm thinking of all the questions that I thought that we're going to have tonight.
Are you getting something out of this, Kevin?
Oh yeah. I'm actually learning a lot. So
good.
But no, the reason why I was asking because man, it's getting late. I know it's probably almost 11 o'clock out there on the East Coast.
Yeah, we're running about 10:30, 10:40 almost.
Kevin, if you don't have any more questions, we'll cut it free, man. I appreciate Ed. I appreciate you coming on. Go ahead, Kev.
I would love to do another one day. Maybe go over some more hardware, some like service related stuff.
Yeah, why don't we do this? Why don't we plan on doing another one? You guys can post my email address, and if there's any techs in the field that have questions they want us to cover on the next one, I can actually prepare those in advance, make sure I have all of the answers, and we can go through it again.
His inbox is going to blow up.
Yeah.
No, it's good though, because look, I used to work commissioning systems, right? And my frustration was always, I'm in the field. Why am I seeing the same problem on 3 or 4 sites, right? When Honeywell called and said, "Hey, do you want to come work for us?" I was like, "What do you want me to do?" They're like, "We want you to work as a sales engineer." I was like, "Yes, because I can go to the front of the line. I can help eliminate those issues downstream. I can help get more information out there to techs, and just make people more knowledgeable about what we're doing and try to do it better." So getting in front of it to me